All right, let's get going. Good afternoon, everybody. Welcome to another exciting but overcast afternoon of organic chemistry with your host, me, Dr. White. And we got a lot to do today. But before I forget, which I probably would, so I better do it now, let me give you a game plan for this week and next week. All right, this week, today, I'll be going through test number 4 answers, and I'll also start my world famous review for the final exam. We'll do that today and Wednesday. Don't forget tonight, I have my office hours. So if you have any questions, feel free to stop by. Now, and I'll mention to go over this in a little while. Next Monday, a week from today, will be the final exam. We will not have lecture. What I will do, and I'll talk about it more, is give it to you start during our lecture period, which is what I could have done all semester, but I think it worked out good. But because of finals week in my schedule, I'm switching to what I'll do. I'll explain that in a little while. Now, ECC is weird because it doesn't have an actual finals week. And because of the contract with all faculty, next week we'll have the final on Monday. By hopefully Sunday, I should, or earlier, get your all points for everything in D2L and your final exam grade. Also post your grade to the school system. But you'll see it earlier from D2L, because sometimes after I post it in the school system, what is it, My Access or ECC Access, I think it's ECC Access. Both schools use Access in their name. I get them confused. But anyways, takes up to sometimes 24, 48 hours before you see it, but you'll see it first in D2L. Next week, I'm required, it's stupid, but I'm required to show up, not only me, but all faculty, to my Wednesday class. You don't have to, because we're done. But if you want to stop by and say hello, feel free to. I'll stick around for a half hour or so. If nobody shows up, I'll say goodbye, because we're not going to have a lab. We're not going to have any more lecture because I've given the final. Excuse me. And I'll also have my office hours next Monday and Wednesday night, because I'm required to per the contract, not only me, but all faculty. A couple of years ago, the academic vice president sent out a pretty strong email saying you can get in a lot of trouble if the last week you don't have classes. Because in the past, before that letter, I had my final. I wouldn't show up on Wednesday when we were face to face. And I wasn't the only faculty doing that. But anyways, I thought I'd give you a heads up on that. Now, another thing I do want, well, let's go through it first, and then I'll talk about other stuff. Everybody see the beginning of D2L on your screen? Anybody ever wonder what that is a picture of? That's a very fancy condenser, not the kind I showed you. I use these in grad school. That's why I picked that picture, which is organic chemistry. All right. Everybody see Chem 170 final information? All right, let's go through this. The final exam will be on Monday, now a week from today at 1 p.m. At that time, I will email you the password. You'll have until Tuesday, okay, I gave you until Tuesday morning, 10 a.m. to finish the final exam and upload your answers to the final exam as a PDF file. Listen carefully. I reserve the right to subtract up to 50, yes, 50 points for anyone who does not follow instructions or anyone who does not upload your final exam on time, unless there's some emergency. All right, please take up to 3 hours to finish this. Most students, when we're face-to-face, usually need between 75 minutes and 90. You're given 2 hours. All right, the final exam, and relax, I'll explain. Take a deep breath, has 32 problems, 18 pages. Some of the problems are multiple part, never multiple choice. Now, the point breakdown. First of all, we have 30 points general knowledge. What's general knowledge? How many bonds to carbon? No, not 5, 4. And we have nomenclature. Those are the type of questions like, here's the structure, give the IUPAC name. Here's the name, draw the structure, and reactions. I forgot how many, but there are a couple of synthesis on there. I forgot how many, but not the majority. Now, another way to break down the points are test 1, 35-point material on test 1. I had 35 points in the final. Test 2, 60. Test 3, 58. Test 4, 53. And new material, proteins and amino acids, 4. It adds up to 210. And there are 10 bonus points on the final exam. Now, one might ask, how come you only got 35 points on test 1 material? Well, I'm not going to ask you at this point because you all know how to do it. How many carbons is the longest chain? Use that information now for IUPAC names. So I'm not going to have a problem or anything like that on there, like I did on test number 1. Now on Sunday, sometime the afternoon or early morning, I'll post the final exam and also a file, which I don't think by now any of you need, but I'll still have it, how to create a single PDF file from your answers with your cell phone if you don't have a scanner. And if you have any questions during the test, email me on Monday or Tuesday while you're doing that. Or I should have also put there, stop by my office hour questions. You know, there's no such thing as a dumb question. Now, there'll be no Zoom meeting on next Monday, but I will have my office hours. And I'll be posting final exam scores along with your final exam grade by 1 p.m. the Sunday after the final or earlier on D2L. I'll also put it in there. At that time, I'll post an announcement, send you an email that your scores in final grade are in D2L. And I'll remind you that it'll take up to 24 hours or more before you see the official grade through ECC access. Any questions on that? All right. One thing I should tell you to make your life easier, don't tell anybody I'm being nice, okay? The final setup material from the first test at the beginning of the final, then test number 2 in the final, then test number 3 material, test number 4 at the end, amino acids and protein material. And that's how I'll do it. How do you study for the final? The best way I'd recommend is use your hourly exams as practice problems. If you can do those, you'll be in good shape. You could also do the other practice problems and stick around today and Wednesday for my reviews, which helps students. And when you look at the final and you say, oh, 18 pages and everything, take a deep breath, let it out, take a deep breath, let it out. Most, like the majority of the students, when I do face-to-face, I give a very similar final, almost identical in terms of length and problems. I just change things around each semester because I rewrite the final. When we do it face-to-face, students have 2 hours to take it. Most students are finished in about 75 minutes. an hour and 15 to an hour and 25 minutes. And they finish early, just like my test. Most of you, I'm sure, finished early. Didn't take you hours and hours. I don't write tests like that. It's not fair. Dr. White tries to be fair. All right, everybody see test key on there? Thank you. All right, let's go through this. And, oh, before we go through this, as always, you should never, ever be penalized for a mistake I make on grading your exam. And therefore, check. If you do, don't tell me now. Send me an email or come to my office hours and I will correct it. I always have. I never penalize a student for something mistake I make. So you should check your exam. I sent everybody emails with your individual points for each answer on test 4. All right. Well, if I were in your shoes, well, it'd probably hurt my feet because I've got big feet. But anyways, anybody out there triple E with? No. See, I told you it hurt my feet. Well, anyways, if I were in your shoes, one of the questions I would ask is, one, what grade, where do I stand in this class? Or a better question is, how many points do I need on the final to get the grade I want? And I'm going to show you that. That's not what I want. All right, everybody see my whiteboard? Now, the following is based on the assumption you have handed in all your labs, which is about most of you have. If you haven't, this doesn't work, what I'm going to teach you. But if you've added in all your labs and you've done well, and everybody who's handed in labs done well, I am not a tough grader on labs. I don't use the lab as an excuse to lower your grade. Now, watch closely. Now, let's assume Y, that looks more like a G. Let me fix that. That looks like a Y. This is the sum of your 3 highest test scores plus your extra credit project. If you go to D2L, you will find I have this total. It's right next to the right of test number 4 points. And also in D2L, if you handed it in, I have graded your extra credit project. And that's way to the left on the D2L grade book of yours. Now, again, this is assuming you've handed in all your tests, all your labs, and let's look at the following. All right, everybody see on the screen right now, points needed to get the following grade. To get an A, you would need 450 minus Y. That's the minimum points you need to get an A, assuming you've done all your labs and you've done well. And most of you have done either 10s or not, 10 or 11s on your labs, which is why I'm excluding it, because it's not going to hurt you. And unless you, anything lower, it won't. Anyways, this works, and I've been doing this for years. For B, it's 400 minus Y is the points needed. For C, 350 minus Y, and D, 300 minus Y. Now, let's assume you did real good, and Dr. White's being lazy now. And on the 3 tests, you got 100, or all 4 tests. So your Y, and you didn't do an extra credit, Y equals 300. To get an A, 450 minus 300, keep an eye on my math, so I'm doing this in my head, you'd need 150 points. And you say, 150 points? Well, to put it in perspective, the final is essentially like 2 hourly exams. So if you divide that 150 by 2, you get 75, and that would be the same as if you had to only get a 75 on the hourly exam. So does that help everybody get a feel for what you need on the final? A lot of you are in good shape, which makes me feel good, like most of you. All right. However, I have a warning for you. Can I have everybody's attention? A lot of you are in good shape, and you say, oh, I don't need that many points on the final. And over the years, I've seen this happen a number of times. A student will be in that position, and they don't study for the final. And guess what? They do horrible on the final. They still use the term, they blow the final. You still use that term? All right, they blow the final. And because of that, instead of, let's use an example, they could have gotten an A, they studied a little, they get a B, or at one time a C, where they should have had an A. So even though you don't need a lot of points, or you don't need to do like perfect score in the final to get your A, study as if you need every single point. And that way, you'll do good on the final and you'll get your good grade. But this also shows you that for those who've done well during the semester, you're in pretty good shape. Any questions about that? Check my chat. No. All right, it's time to start Dr. White's review for the final exam. As I mentioned earlier, the final exam will be a week from today during our class, and therefore we'll not have lecture. I will have my office hour, and I'll check my email if you have questions during the final exam. And I'll be given like we've done the hourly exams. But let's go to the review. Now, the review I'm going to do everybody see test 1 review on your screen? This is still in the lecture folder of Blackboard, but me going over it helps you out. Do better. All right, let's start. We started out long time ago. Doesn't it seem like a long time ago, like how well you've learned organic chemistry? I talked about hydrocarbons, and you should know, hint, that a hydrocarbon molecule or hydrocarbons are molecules with only carbon and hydrogen atoms. And then when we talk about hydrocarbons, there's 2 types. And again, everything you see here is in the folders. This one secretly named test number 1 review in the lecture section. A saturated hydrocarbon is a molecule with only carbon hydrogen atoms and only a carbon-carbon single bond. And Unsaturated hydrocarbon is a molecule with only carbon hydrogen atoms and at least one carbon-carbon double bond or triple bond. And that's an unsaturated hydrocarbon. I'll let you catch up. Anybody think about ketchup, how organic it is? Whether or not it says organic on the bottle, the ingredients are organic chemicals. All right. Now, next I started teaching about the alkanes, which I will never ask the definition on a final, and that's an acyclic saturated hydrocarbon. And A means without a ring, A's without cyclic ring. I talked about the cycloalkanes, which are saturated hydrocarbons that are rings. I taught you how to draw them. And at this point, I'll have to be honest with you, I started brainwashing you, and I did a good job. How many bonds to carbon? And it's funny, I've met students a couple of years after they've been in my class, and how you doing? And say, good, I still remember this. And I did that on purpose because it helped you a whole semester. Now, how to draw. And then I taught you about IUPAC, which I'll never ask, but I like to say International Union of Pure Applied Chemistry. This sounds cool to say that. And I talked to you about how this is the international agency that set up the rules for naming all chemicals, but the bulk of the chemicals in their rules are organic chemicals. Organic chemistry is the best, but I'm biased. And I showed you how to find the longest chain of a compound. And then I talked about how there's the root name, the alkanes 1 through 10. 1 is methane, 5 is pentane, 7 is heptane, 10 is decane. It goes higher, but this is enough. And I talked about the various methyl alkyl groups that are branches of the longest chain. And it's your old friend now, the methyl group, CH3. 2 carbons bond to the end carbon, ethyl. 3 carbons, there's 2 choices. 3 carbons to the end, carbon and propyl. 3 carbons to the center one, isopropyl. And then 4 carbons, there are 3 of them, but the one I didn't show you, I have never used in my career, which means you're probably never going to see it because I've been doing it a few more months than you have. Well, a few more months. 4 carbons and carbon N-butyl, 4 carbons, 3 carbons to the center carbon to the chain or ring. T-butyl, or organic chemists are lazy, we just call it T-butyl. Either one is accepted on the test. Oh, look, Dr. White spelling error. Have you ever seen gooseline? Anyways, real world uses, gasoline is an alkane, propane for your barbecue is an alkane, natural gas, methane, Vaseline, baby oil. And when I ask on a test, give an example of an alkane you could use in your daily life. And the answer is, I did. Or if I do a generation gap thing, you bet your sweet dippy. That came from Laughing, which I think most of you have never seen. It's a funny program. I'm surprised they don't have, well, I know why, probably now they don't have reruns because it's not PC, politically correct for this era. Back then it was. So let's still have a little fun. And the question is, give the IUPAC name for the following molecule. And I figured I should share some fun. And this is part of the reason my reviews help, because I also have you practice a few things. And this way I know you'll have at least 4 hours of review with Dr. White. And when you're done, give me a thumbs up. And for those of you who don't have your webcam on, you can use the Symboli, the new name I gave for emojis. All right, looks like everybody's done. Let's do this. First of all, you have to find the longest chain. And you could either do 1, 2, 3, 4, 5, 6, 7, 8, 9, or 1, 2, 3, 4, 5, 6, 7, 8. And I hope you all agree 9 is greater than 8. The longest chain, which you don't have to on a test market, but a lot of you got similar on test 1 wrong, is 9 carbons. And what is that? That's no name. Next, we have 1, 2 methyl groups. And when you have 2 of the same, that's di. And you notice it's on carbon 3 and 5. So that would be 3,5-dimethyl nonane. And why don't you all draw the structure for isopropyl cyclohexane? Oh no, I got a bright spot on my forehead. I better wear a hat. And when you're done, give me a thumbs up. All right, I see all the thumbs popping up, so I better get to work. How do you do this? You start from the right, move left. Hexane, 6 carbons. Cyclo, a ring. Isopropyl, 3 carbons, center carbon. You can put it on any carbon. Most of you are probably going to do this. And let's do one more. Give the IUPAC name for the following. And why don't you give the IUPAC name for that molecule? I know work you guys today. I've done that all semester. Have you noticed how it's paid off? And for those of you who have your webcam on, thank you. You're real people out there, not just names on a screen. Thank you. Anybody need, it looks like everybody's giving me that look. Get to work, Dr. White. So I will. All right. What do we have here? We have a ring. How many carbons? Every bend of the line is a carbon. So there are 5 carbons. That's pentane. Remember, for a ring, you have to put cyclopentane. Students forget to do this. Don't. Then on the same carbon, I have a methyl group and an ethyl group. And this would be 1 ethyl. When you have more than one group, you do need numbers. 1 methyl, cyclopentane. If I look at the clock, guess what? It's time for a break. So I'll see you in 5 minutes at 1:55. Do come back. Time to start. All right, let's get going. Now, the next thing I taught you about, which was a big gift, is organic chemists are lazy. You haven't figured that out by now. And when we don't have to balance an equation, we don't. We're just interested in the product or products. And I talked to you about what's called general reaction. Oh, look, Gooseline is still there. If anybody gets a good deal on Gooseline, let me know. But anyways, I talked to you about general reactions. And the first one I taught you was an alkane or cycloalkane plus oxygen gives CO2 and water. And with that, I thought I'd share. Everybody see the whiteboard? And that is take that molecule, react with oxygen. What do you get? What are all the products at this point? I haven't used this in a while. All right, looks like everybody's done. And if you look at this, how do you do these types of reactions? You look here and say, what kind of molecule is that? That's an alkane. I can spell it. Hey, I told you Dr. White's always been the first one down in spelling bee. Or it could have been a cycloalkane. And plus oxygen gives you CO2 plus water. And here the answer is, guess what? CO2 and water. And that's chapter 1 material. Nope, I'm not done yet. What am I saying? Got ahead of myself. Now I've got to. All right, next thing I talked about, everybody see alkenes and alkynes? Thank you. The alkenes, double bond. Alkynes, triple bond. Each line is a chemical bond. 2 lines, double bond. Each line stands for 2 electrons. And not all bonds are created equal. In a double bond, you should know, has 1 sigma bond, 1 pi bond. In the triple bond, we have 2 pi bonds, 1 sigma bond. Now, this was a mistake. It should have been for IUPAC names, double bond, drop the ANE ending, not just the E, replace it with ENE for double bond. When it's acyclic, you need a number, which carbon is the closest carbon to the 2 carbons of the double bond to the end of the chain. Plus, you may need cis or trans. Send a ring, you need node number. It's the only functional group. That double bond carbon will always be 1. So let's take a look at what that means. And if we look at these two molecules, they both have 4 carbons. They both have a double bond, and the double bond starts at carbon 2. So these would both be 2 4 carbons butane, drop the ANE, add ENE. Now, if we draw a plane right there that's orthogonal, like if your hand was coming out straight from those carbons, you'd see these 2 carbons aren't the same, and we call that cis. So that's cis-2-butene. These two, I said carbohydrates, these 2 hydrogens are opposite of the plane on this side and this side, and we call that trans. And that's how you do cis and trans. And with that, everybody see that on the screen right now? Give the IUPAC name for that molecule. Go. And when you're done, give me a thumbs up. I see everybody's working on their problems. Thank you. It makes me feel good. All right, I think everybody's done. Let's do this. At this point, I started brainwashing you. When you look at an organic molecule, look for something different. What's not a carbon-carbon single bond or carbon or hydrogen, that's where the action and fun is. And there are 2 things for the final you should remember. That's one. Remember, there's 4, yes, 4 bonds to carbon. And that will always be your friend. So we have a double bond. How many carbons in the longest chain? 1, 2, 3, and it has to include both carbons. 4, 5, this would be 6, but this is 6, 7, 8. Double bond, longest chain, octane, 8 carbons. Double bond, drop the ANE, put ENE, octene. The lead carbon closest to the end of the chain is 3, so it's 3-octane. Notice I have this hydrogen and this hydrogen. They're opposite this plane, so that's trans. And on carbon 5, I have a methyl. So that'd be 5-methyl trans 3-octene. And that's how you do it. And why don't you draw the following molecule, 4-T-butyl cyclohexene. That's the ENE. There you go, cyclohexane. Oh, shucks, I shouldn't have shown you that one. That would have been a good final exam question. All right, looks like everybody's done. Let me get to work. How do you decode this to know what to draw? You start from the right, move left. ENE ending, double bond. That was ANE, cyclohexane, which is this ring. As a double bond, I'll put it there. You can put it anywhere. I'll call this carbon 1 and this carbon 2. Because the carbons, the double bond or ring, one always has to be 1 when there are no other functional groups, which is the case in this course, and the others 2. And then I see, oh, a T-butyl group on carbon 4, so this has to be 3, that's 4. T-butyl group, 4 carbons. And that's how you do it. Now, for a triple bond, you drop the whole A and E, not just the E, and replace it with Y and E and the number. So triple bond, and the number is 1 and 2 carbons of the triple bond. Which one is closest to the end of the chain? Remember, you can count from either side of the chain. And let's do one. And there's no cis or trans. And why don't you give the IUPAC name for the following molecule? All right, when you're done, give me a thumbs up. I see a lot of thumbs, so I better get to work. And what do we see that's different? Triple bond. How many carbons is the longest chain? 1, 2, 3, 4, 5, 6. I call this 7 or this 7, doesn't matter. You get the same name. 7, heptane. Drop the ANE ending. Triple bond is YNE. So heptyne. What carbon is the lead carbon? 2. So the triple bond, 2-heptyne. And it's your old friend on carbon 6, methyl. So 6-methyl, 2-heptyne. One thing I just remembered, no, I shouldn't have had a V8. I've been brainwashed by TV commercials, but listen carefully. Unlike test 1, 2, 3, and 4, and the same thing if we were face to face, I do not hand back the final. I don't. It's less work for me, and I'm busy enough at the end of the semester. What I will tell you is, A, you do get your total score, and B, and this is why I wanted to tell you, if any student is within 10 points of a cutoff, I will automatically go back and totally regrade the whole final. This way, if I made a mistake, I will catch it. Now, honestly, all the years I've been doing this, the worst case I've ever seen was when I had a 2-point error. I rarely make errors, but I still go back and grade it. But it's only happened once in all the years I've been at ECC. A student has contested a grade, then I'll bring in the final. We have a meeting with the dean. But I don't give back, and I won't email back your points for each part on the final. It's just a lot of work, and I'm busy enough. So I just let you know. All right. So we've done nomenclature. Now, double bonds. And here's where I started showing you, and definitely the beauty, the strength of learning functional group analysis or organic chemistry. And you look at a functional group and they undergo reaction with certain reagents always the same way. No matter what type of molecule you're in, that's what they're going to do. Just like if you see over here, you see a door going out of my office to the rest of my house. And if you look at the front door of my house, it's not going to look like that door. But you know the function of a door to go from one space to another. And so I know how to use a door. And you do too, I hope. And the same thing with functional groups. And the first one I showed you was you take a double bond, react it with hydrogen and catalyst, and the catalyst can be nickel, platinum, or palladium. You break the pi bond, and each carbon gets a hydrogen. Again, double bond, you break the pi bond, and each carbon of the double bond gets a hydrogen. And this time, I started teaching you the most third thing is you break carbon-carbon single bonds. In my course, other than burning it, combustion, no, never. Once I started brainwashing students, the scores went up because students were doing the wildest thing, and he was always wrong. So let's take a look. I'll do one, and then I'll let you try one. Now, if we look at the following, and I'll do this one, what's different? Oh, a double bond. And immediately, this is all I see because the rest are carbon-carbon, single bonds and hydrogen. So nothing's going to happen there. I have hydrogen, nickel is a catalyst. Remember, the catalysts are nickel, platinum, or palladium. And you break the pi bond, and each carbon gets, of the double bond, gets a hydrogen. Do you break carbon-carbon single bonds? No. So you're going to have 4 carbons. These are my 2 carbons of the double bond. No, you don't have to put dots in there. That's going to stay the same. Each carbon gets the double bond gets a hydrogen. If you notice, I broke the pi bond, and then 4 bonds to carbon. So this has 2 hydrogens, this has 1. You could have written this one CH2, CH3, but it's less work, and that's how you do it. And there's one for you to have fun with. What would be the organic product or products for following reaction? Have fun. And by the way, during the break, I went down to my living room, looked out. I have a big picture window in my living room, most houses do. And I called my weather window. I got to see the sun was out. Yay. All right, I think everybody's done. Everybody, are you done? All right, let's do it. What do we see that's different? Double bond. What are we reacting it with? Hydrogen and a catalyst. And the catalyst can be nickel, platinum, or palladium. In this case, it is platinum. And you break the pi bond, and each carbon gets a hydrogen. Now I have 1, 2, 3, 4, 5 across. I better end up with 5 across. These 2 carbons are my double bond. I broke the pi bond, and they also have carbons here, methyls. I know there's 4 bonds to carbon, so I can immediately put in hydrogens. And each one gets a hydrogen. And that's how you do it. Now, next general reaction, double bond plus halogen gas. X in organic chemistry, I taught you, is can be either fluorine, chlorine, bromine, or iodide in this reaction, the halogens. And the same thing happens. You break the pi bond, and each carbon of the double bond gets a halogen. Now, these are symmetrical additions. Notice both carbons either get hydrogen or halogen. What happens when you get unsymmetrical addition? Double bond plus HX. HX is the hydrohalogen axis. And in real life, X now is this chlorine, bromine, or iodine. You break the pi bond. One carbon gets H, the other gets the X. How do you know which? It follows Markov-Nichols rule. The carbon with the most hydrogens in the double bond gets the hydrogen, the other carbon gets the halogen, otherwise known as the rich get richer and the poor get poorer, which I learned a long time ago. I still remember. Now, if we look at the following, I'll do this one. What's different? Oh, a double bond. What are we reacting with? HCl, which is HX. Remember, for this reaction, X can be chlorine, bromine, or iodine. You break the pi bond, and one carbon gets H, the other gets X. It follows Markov-Nichols rule. The carbon with the most hydrogens gets the hydrogen, and the other carbon gets the halogen. So if we look at these 2 carbons, this has 2 hydrogens, this has 1. Remember the tough math we've done all year, and I didn't even let you use a calculator. You have to know which is the bigger number. Hopefully I'll pick 2. So that means the hydrogen will go there. Do you break carbon-carbon single bonds? No. Hydrogen goes to that carbon. The other carbon gets the chlorine, and that counts as a bond, so I can know how to put in my hydrogens, and that's how you do it.
Question?
Answer. I don't know the question yet, so
I should have asked this question 2.5 months ago, but why isn't fluorine included in the as X?
Because hydrogen fluoride, it probably would work as a very dangerous chemical. And most of the time, you want to stay as far away from it as possible.
Okay.
Or in real life, I have never seen anybody take a double bond and add HX to it.
Okay.
The only time my whole career when I was a bench chemist, which was 2 years, or even working in grad school, that I ever refused to do work with a reagent was when I was at Axel, and they asked me, would you work on this project? I said, no, if you force me, I'm going to find another job. And they found someone else, and he almost had a nervous breakdown working not this reaction, but something else with HF. And it's just very, very dangerous. And that's my time.
Okay.
Good question. It's the only reagent I've ever said, no way, I'm not going to touch that stuff. And I won't. Anyways, your turn. Give the organic product or products for the following products. Remember, 4 bonds to carbon. All right, looks like everybody's done. I better get to work. Now we look at here and say, what's different? Ooh, a double bond. We're adding HBr, which is HX. X can be chlorine, bromine, or iodide. Break the pi bond. One carbon gets H, the other X, and it follows Markov-Nikolov rule. And that is the carbon double bond with the most hydrogens gets the other, gets the hydrogen, the other carbon gets the L. Oh no, there are no hydrogens. Yes, there are. Count the bonds here. This carbon has 4 bonds to it, so it has 0 hydrogens. This carbon has 3 bonds to it, so it has 1 hydrogen. Which is greater? Hopefully I'll pick 1. You break carbon-carbon single bonds? No. And I'm done. Remember, you don't show hydrogens on a ring. This now has 2 hydrogens, and I added it. No, I'm not done. I'm sorry. I was thinking another problem. And this gets the bromine. Now I'm done. If you put the bromine over here, the methyl over here, that's fine. And that's how you do it. Now, I also showed you, you can add water to double bond. Here we're using H+. And H+ is the generic way of saying an acid. And there are a couple of acids you could have used here. Sulfuric acid, acids I haven't taught you this semester, like methane sulfonic acid and toluene sulfonic acid. But think of water as HOH. One carbon double bond gets H, the other gets the OH hydroxyl, and it also follows Markov-Nikolov rule. Now, when we come to triple bonds, you have 2 pi bonds, and therefore each one reacts just like a double bond, but now we need more hydrogen in this case. So instead of balancing the equation, we just put down bracket excess, close bracket, which means we have enough hydrogen in the world that will react with anything hydrogen can react with. And since there's 2 pi bonds, each carbon in a triple bond gets 2 hydrogens. Same thing for halogenation. And here, just like in double bond, X2 can be fluorine, chlorine, bromine, or iodine. chlorine gas is not as dangerous to work with as hydrogen fluoride, even though the halogen gases, you have to be careful. I almost burned myself once with chlorine gas. You don't want to have that happen ever. Anyways, you break the 2 pi bonds and each carbon gets 2 halogens. Again, so we don't have to balance it, we use the letters bracket, excess, close bracket. You can use it other places too. That means you have enough of that reagent, in this case halogen gas, to react whatever halogen gas could react with, the 2 pi bonds. Now, next I taught you about aromatic compounds. Remember, we had that fun lab, which I'm so sad you didn't get to smell some neat stuff. But if you ever want to, how many of you have vanilla in your house? Go smell some. Did I tell you about the best place to get double strength vanilla in Madagascar? Thank you. But anyways, I should get kickbacks from those companies. Aromatic compounds have increased stability and they have an aroma. And the simplest one is benzene. And IUPAC said, let's take the ancient name that everybody uses and we'll make it also the IUPAC. Now, benzene is a 6-membered ring with 3 double bonds. You can write it this way, or this way. If you don't put the lines, double bonds, or a circle, that's cyclohexane, and I'll mark it wrong. And I warned you, go back and look at the video. Oh, that's right. I got video evidence of what I said. That's dangerous. But anyways, this is benzene. Now, when you have a methyl group on a benzene ring, again, that's an ancient name, and that is not called methylbenzene. It's called toluene. Again, don't forget the lines here. Now, when you have disubstituted, meaning 2 groups, we don't use numbers, we use the words ortho, meta, and para. Ortho is 1,2 disubstituted. Meta is 1,3 disubstituted. Para is 1,4. For those of you writing this down, don't forget this is all in Blackboard School D2L. Important information, the lecture test number 1 review. And why don't you give the IUPAC name for the following molecule? If you know anybody you want to be really cruel to, tell them either this summer or next fall, I'm teaching Chem 170. Hopefully you enjoyed your time with me. I've gotten to enjoy meeting a number of you. Thank you. All right, looks like everybody's done. What do we see? Oh, a benzene ring. And it's disubstituted. We have an N-propyl and an ethyl. So this would be ethyl, N-propyl. But since I'm not holding you to the alphabet rule, you could have also put N-propyl ethyl. And notice this is 1, 2, 3, 4 disubstituted, 4 disubstituted is para. So it's para-ethyl and propyl benzene. Oh, I can't resist this one. Everybody remember what that is? Yep, it's paramedic. Oh, that reminds me, in double bonds, I forgot to do this one. And you know that's transparent. Watch out, I'll start doing my magic tricks. One thing, let's do one. Why don't you do that one? Draw the structure of benzene. I think everybody's done. Now, remember, benzene, I can draw these resonance forms, which I think are the cooler way to go with benzene, but you can also, those are called the Kekula structures, or put the circle. If you were to draw this is cyclohexane, and I'll mark it wrong every day of the week and the weekend too. Remember, you need to put either this in or the bonds in for either benzene or toluene. At this point, I introduced some new substituents. Chlorine is called chloral group, F fluorine, fluoro, Br bromo, for bromate, iodine is iodo, and nitro NO2 group. And what's the IUPAC name for the following? Remember, 2 is di, 3 is tri. I've never used 4, which is tetra. I did. I used to use the joke tetramethyl chicken wire that went over like a lead balloon. Let me just check something quick. Yes, I am. All right, I think everybody's done. What do we have here? Benzene ring? No. Methyl group on a benzene, toluene. And I have, nitro group, not 1, not 2, but 3. Trinitro. And notice if this is 1, they're on 2, 3, 4, 5, 6. When you have more than 2 groups on a benzene ring, you use numbers. So it's 2, 4, 6 trinitrotoluene, otherwise known as TNT. Boom. I had that in test 1. Now, since I wasn't going to teach you directors, some of these reactions are only what you see is what I can give. With a benzene ring, you do not want to break the double bonds. Why? Because you lose what's called the resonance stability of the ring. And they don't. But you can replace the hydrogen on the ring. And the first one is halogenation. You take halogen gas, and I've only seen it done for chlorine or bromine. I don't know if anybody has ever tried fluorine or iodine, but for this, and you need a catalyst now, ferric trihalide, you replace the hydrogen with the halogen. And as we learned in the lab where you made bromonitrobenzene, they're directors. And I'm not going to teach you that in the lecture part. And therefore, there's only two examples I can give you for this one, when X is chlorine or fluorine. Next, take benzene ring and react it with nitric and sulfuric acid. And this forms NO2 cation, which attacks the ring. These are all electrophilic substitution reactions, aromatic substitution reactions. And you replace one of the hydrogen with a nitro. You put NO3, I'll mark it wrong. Nitro group NO2. And this is the only reaction I can ask you on the final, because we're not doing directors. Next, I have sulfur trioxide, sulfuric acid, and you put a sulfonic acid group. And this is used to make detergents from benzene, which comes from petroleum oil. And remember the H. If you put SO3, I mark it wrong, because this actually is sulfonic acid, SO3H. I can't ask you anything else. And then I introduce you to one of those special reactions where you can make a carbon-carbon single bond. And that's Friedel-Crafts alkylation, putting an alkyl group, an R group, on a benzene ring. Remember, the carbon with the halogen, in this case, halogen is usually bromine or chlorine, otherwise it's not economically feasible for various reasons. And it's the one bonded to the benzene ring. And since I'm going to have some synthesis problems on the final exam, what two molecules would I react to make with aluminum trichloride to make that molecule? And this is the fun part of organic chemistry. All right, Tom, if you need to, feel free. Don't forget, sometime tomorrow, I'll be posting the video for today. So I hope you feel better. Gehen gesund. I know what was it, October, I had two bad Charlie horses. I woke up in the middle of the night and I was walking them off in the front part of my legs, and I tripped on something or whatever, and I crumbled, and I caught myself, but in a way I twisted the lower muscles of my back, and that was not fun for a long time. I actually had to go to physical therapy. And it took a good 10 weeks before it was back to normal. Even now, it's still will tighten up a little. All right, when you're done, give me a thumbs up. By the way, you can always put a little thumb face on your thumb. No, I'm just kidding. All right, let's do this. What's different? Ooh, a benzene ring, but it's got an R group on there. And how do you do that? And what do you react? Benzene plus Rx. In this case, X is chlorine. One of the question marks, and it doesn't matter which one you put first, is benzene. Here's our R group. The carbon bonded to the benzene ring is the carbon that will have the halogen. So I have 4 carbons, and the N carbon will have the halogen, chlorine. I know there are 4 bonds to carbon. And that's how you do it. And now I can say we're done with the stuff for test number 1. Let's move on to test number 2 material. And everybody see alcohols on their screen? Thank you. All right, first of all, new functional group. Carbons, remember at this point in the reaction before, I taught you R was just like X and Y in math, but for organic chemistry, it's just something that has carbon and hydrogens in it. If you have a carbon with OH, hydroxyl, it's an alcohol. How do you name alcohols? You drop the E, find the longest chain with the carbon with the hydroxyl group, and you drop the E, add OL, and use a number for acyclic. If it's on a ring, no number, that carbon's always going to be 1. Now, there's a special name you needed to know, and that was phenol. And phenol, not phenol, but phenol is a benzene ring with a hydroxyl group. And that's phenol. Now, I also taught you common names, which at this point, throughout the semester, on my test, and it'll be true on the final, on when it deals with common names, I will never ask you, here's a molecule, except for amines, I take that back, but other than amines, I'll never ask you for anything else. Here's the molecule, what's its common name? But I will ask you, here's the common name, draw the molecule. And why? Because those are things you're going to see on ingredients labels. Now, if we look here, how do you do common names? R group, name it as an alkyl group it is, then add the word alcohol at the end. And as I taught you, rubbing alcohol is 70% isopropyl alcohol, 30% water. Sometimes this number is even higher. And I would ask you, give the IUPAC name for the following molecule. And I will. So, your turn. All right, I think, is everybody done? All right, I'm seeing everybody's thumbs. I better do it too. So, what's the longest chain? Well, you can go 1, 2, 3, and there's another way. That'd be propane. I look for what's different. Oxygen with a hydrogen and a carbon, alcohol, OL ending. What carbon is it on? Carbon 2-propanol. We also have a methyl group. So this would be 2-methyl, 2-propanol. If I look at the clock, it's time for a break. I'll see you in 5. Actually, I went over. Let's come back at 250, 251. That way I'm not cheating you out of anything. See you in 5. Time to get back to work. Boy, I haven't used this one in a long time. All right, talking about alcohols. And how do you make an alcohol? I see a question. Hi, Tom, glad you're back. All right, we already did this reaction. You take a double bond, react it with acid water. Remember, water is HOH. Break the pi bond, one carbon gets H, the other gets OH. And it follows Markov-Nikols's rule. The carbon with the most hydrogen gets the hydrogen, the other gets the hydroxyl group. Now, next, we did one of the probably most difficult reactions for most of you, and that's reaction of an alcohol with acid and heat. It's called dehydration. You lose a hydroxyl group, an adjacent hydrogen, carbon one next to it, bonded to the carbon with the hydroxyl with a hydrogen, and you form a double bond. And it follows Z's rule, and you get the double bond that has the most carbon atoms attached to it. Again, you get the double bond with the most atoms, carbon atoms directly attached to the carbon of the double bond. Everybody see the whiteboard? I'll do this one. Because I can go Technicolor. Notice on this carbon here, I have my hydroxyl group. If I lose the hydrogen, first of all, general reaction, carbon with a hydroxyl group, adjacent carbon with a hydrogen, sulfuric acid and heat. And I sometimes put temperature down there, but this triangle means like heat, sulfuric acid, H2SO4. You form a double bond and it follows Z's rule. And Z's rule tells you you get the molecule that has the most carbon atoms directly bond to the carbon atoms double bond. If I lose the hydroxyl group and a hydrogen from carbon A, remember you don't break carbon, carbon single bonds, I'll form this alkene. If I lose the hydroxyl group here and the hydrogen on carbon B, I'll get this double bond. And how do you apply Z's rule? We go Technicolor. How many carbon atoms in A bonded to the carbon atoms double bond? And the answer is this one, 1. And if I look at B, how many carbon atoms are directly bonded to the carbon atoms of the double bond? And the answer is 3. And now you have to use your high-level math skill, which is larger number. Hopefully I'll pick 3. And this is the product you get. In real life, one you get 90%, the other it's about 10%. But to make your life easier, I just said that's the one you get. Now, if you have an alcohol and react it with HX, or X can be chlorine, bromine, or iodine, you replace the hydroxyl group with the halogen on the carbon that had the hydroxyl group. Now, since HX, as you learned earlier, can react with double bonds, we came up with another reagent that if you take an alcohol and react with thionyl chloride, SOCl2, you replace the hydroxyl group, in this case with chlorine, on the carbon with the hydroxyl group. Next, I talked about primary, secondary, and tertiary alcohols. And you take a primary alcohol, I'll never ask on the final, like I didn't ask on the test number 2, what's a primary, secondary alcohol. If you take a primary alcohol, oxidize it, you remove the hydrogen here and the hydrogen here, and you get an aldehyde. O in a bracket stands for different oxidizing reagents like potassium permanganate, sodium dichloride, no, what am I saying? Sodium chromate, and this will give you an aldehyde. You have a secondary alcohol and oxidize it, lose this hydrogen form a carbon-oxygen double bond, similar to above, but now you get a ketone. Tertiary alcohols will not react. Therefore, quick reminder time. If I ask you give the product or products on a for the following reaction on a test, or in this case, the final, I will never, ever have an example where the right answer is no reaction. That will always be wrong. Always. How do you like that? Always. You're out, you're wrong. So don't ever put down no reaction, because when I was a student, the teacher would do that. Now, other than it get me upset. If you want me to write down the product for a reaction, that no reaction is no product. So I'll never do that. And why don't you give the organic product or product for the following reaction? And don't forget, if you have any questions, stop by my office hours tonight. All right, looks like everybody's done. So what do we have here? Primary alcohol. We're oxidizing it, lose the hydrogen there and there and make an aldehyde. At the time, you didn't know this was an aldehyde. Now you do. Do you break carbon-carbon single bonds? The answer is no. And therefore, I have this carbon right here is this one, which will become this one. Therefore, this is all my R group. 1, 2, 3, methyl. And this carbon is that carbon, which I'll have here. And notice I have 1, 2, 3, 4 plus a methyl group 5. 1, 2, 3, 4 methyl group 5. Oh, let's have some more fun. And what would be the starting material for the following reaction? Isn't it amazing? 6 months ago, would you even know what I'm talking about? Doesn't that feel good? I hope it does. You should be proud of all of you, your achievement. How many of you have heard organic chemistry is real hard and tough, almost impossible? You can smile, you can give me a thumbs up if you heard that lie. It's not true, it's fun. But I'm biased, I'm an organic chemist. All right, let's do this. What's different? Ooh, an oxygen. Double bond to carbon. Well, carbon's here and here. This is a ketone. And what do you oxidize to make a ketone? A secondary alcohol. And I taught you at this point about R and R prime, just like in math, X and Y. These can be the same or different. That's why we use it. Now, here's my carbonyl carbon. The rest of the ring is R and R prime. They're just connected together. So immediately I can draw this, because I know I'm not going to break any carbon-carbon single bonds. This carbon is this carbon, where this carbon right here is this carbon. So that will have a hydroxyl group. You don't show hydrogens, I'm done. Now, the next thing I talked about was thiols. And thiols stink. And if you remember, skunk odor is a mixture of thiols and water. If you've ever smelled an animal that got skunked, you know that stink. And the important thing I taught you was, because thiols are so stinky, and remember that tragedy in Texas, you should remember natural gas, methane has no odor, so does propane. Actually, propane, they put another thiol in, but in natural gas, you can now smell a leak in your house or wherever, because they put a thiol in natural gas. Would I ask a question like that? And the answer is yes, I did. Test number 2. Next, I talked about ethers. Ethers where you have an oxygen, R and R prime ether. I didn't ask you to learn the common names. And actually, I'll hint, I didn't put any questions on the test about nomenclature ethers. But in case you ever ask, you name each R group as the alkyl group it is, and they add the word ether. And as I mentioned, ethers have been used for now since right before the American Civil War as an inhalation anesthetic by the medical profession. And how do you make an ether? Williamson ether synthesis. Take an alkoxide, alkyl halide, X here can be chlorine bromine iodide, and you form an ether. The carbon with the halogen is the carbon the oxygen will bond to, and you make a salt. And the question is, give the organic product or products for the following. Enjoy. Boy, I'm working you hard today. Well, it's the last week I can. Where's my bullwhip? Crack. Oh, remember how the dean asked me a long time ago? Anybody want to hold their answers up to the screen? Anybody have their own electronic tablet? Doesn't work on Zoom, doesn't work in face-to-face either. Don't tell the dean I said that. All right, I think everybody's done. Let's take a look at it. Look at a molecule. Look for what's different. What's not carbon, what's not hydrogen. Should get your attention like that. I just snapped my fingers. Had it on low volume snap. Ooh, that was an awful joke. Anyways, alkoxide, O minus and a plus on with carbons. Carbon, carbon. Ooh, halogen on a carbon. Alkyl halide. What do you get? An ether. What's our methyl? What's our prime? Isopropyl. Well, something got in the way. Sorry about that. Let me move you down here. Our prime is that. So my methyl group, my oxygen, which carbon has the halogen, the center 3, and if you put the isopropyl group on the right, on the left, the methyl on the left, put isopropyl on the left, methyl on the right, that would have been okay also. And that's how, oh, let's have some fun with this. Now, all right. Hold, hang in there. My computer is burping on me. All right, let's see if it works now. Sorry about that. Once in a while, you get technical difficulties. Now it's working. And why don't you do the following? What would I react to things to make this plus this? Oh, quick question for any of you who know ethnic foods in the Schaumburg, Palatine area, or even Streamwood. Is there any good bakeries or anywhere where I can get really good tamales? If you can, email me. Somebody told me some in Elgin, but I'm not going out that way because I'm not teaching there. I'm teaching on Zoom. Or if you know a good place for tamales, I got the hankering for good ones. All right. I forgot to ask. Anybody need extra time? All right, let's do it. What do we have that's different? Look for what's different. Oxygen, carbons, carbons, ether. Ooh, sodium chloride, a salt. And how do I make an ether? Williamson ether synthesis. And you take an alkoxide plus an alkyl halide, or X would be chlorine, bromine, iodine, and you form an ether. Oh, look, this is R. And the side is R prime. And what's X? Chlorine. And therefore, I have this alkoxide plus this alkyl chloride. And that's how you do it. By the way, this is diethyl ether, which I'll never ask on a test. Sometimes it's the most popular of all, widely used of all ethers. Sometimes they just call it ether. And it's very useful, but extremely flammable. Next, I talked about ethylene oxide. At first glance, you say, oh, this is an ether, but no, because it's in a three-membered ring with the oxygen, it has totally different chemistry. And I'll never ask you what's the name of ethylene oxide, but we talked about the first reaction, take an alcohol, react it with ethylene oxide, you get this ether alcohol. Now, if you take the same alcohol or different one and react it with n moles of ethylene oxide, you get this polyether alcohol. Remember, the hydroxyl group goes outside the bracket, not inside, or I'll mark it wrong. And those two reactions, I'll never give a synthesis problem, either on the test or the final, but I will ask you to do the following, give the organic product or products for the following. And when you're done, give me a thumbs up. Those of you who have your webcam off, use the symbolic. All right, looks like everybody's done. Again, it helps to know the general reaction. And what do we have here that's different? Ooh, hydroxyl group on a carbon, alcohol. Plus, ooh, that's unusual, and moles. And what is this? Ethylene oxide. and you form this following poly, remember poly means many, ether, alcohol. In this case, what's R? Methyl. What's N? 5. And that's the molecule you get. And next, I warned you about, and I was, if I look like I'm having too much fun talking about this, I am. This is one of my comfort functional group areas. When I'm under stress, I think about certain functional groups and play with them on paper. And aldehydes and ketones are two of my favorite. They helped me get a PhD. And my last patent, my first patent, I use my knowledge of them. What's an aldehyde? Aldehyde, carbon double bond to oxygen with an H and an R group. Ketone, carbonyl, carbon double bond to oxygen with 2 R groups. Ketone. Let me just check something out. Yep, I have it there. Now, for an aldehyde, find the longest chain that has the carbon double bond to oxygen, which you now know is called the carbonyl carbon, carbon double bond to oxygen, carbonyl carbon. In all of organic chemistry, now I'm being very biased. I know nothing more important to me personally because Dr. White is a carbonyl synthetic organic chemist. That's why I got my PhD in, and I've done a lot of work with them. And you find the longest chain, drop the E, add AL, no number, because you can't have an aldehyde in a ring. And there's one special aldehyde. When R was a benzene ring, IUPAC said, let's take the common name and make it IUPAC. That's called benzaldehyde. Now, for a ketone, carbonyl with 2 R groups, find the longest chain or now ring that has the carbonyl carbon, carbon double bond to oxygen, drop the E, add ONE. For acyclic, you need a number. For cyclic, you don't need a number because the carbonyl carbon is always number 1. It rocks. And that's how you do that. And let's do a quick practice. We got time. And why don't you give the IUPAC name for that molecule? 3 points each. And when you're done, give me a thumbs up or a dirty look like, get to work, Dr. White. All right, I think everybody's done. Let's take a look. First of all, look for what's different. Ooh, oxygen, double bond to carbon, hydrogen, carbons, aldehyde. How many carbons the longest chain? It doesn't matter. I'll do, oops, that way. 1, 2, 3, 4, 5, 6. I could have done 1, 2, 3, 4, 5, 6. You get the same answer either way. 6 is hexane. Drop the E, add Al, hexanal. This carbon is number 1, and you don't have to put that down. This is 2, 3, 4, 2 carbons on carbon 4, ethyl group, 4 ethyl hexanal. And that's how you do it. Make sure your Al and Ol, I can tell the difference. Al, aldehyde, Ol, alcohol. You don't want me guessing. Why don't you draw the following? Draw the following molecule, 3-isopropyl cyclohexanone. I say one person done. Oh, you know what I thought? I could have had you all put red nail polish on your thumb so I can go like this and nah, that's an awful idea. All right, everybody's done. How do you decode this? You start from this end and move that way. O-N-E-N-D, ketone. And if that were E, it would be cyclohexane, which is this molecule. It's a ketone, so I have a carbonyl. This is carbon 1. And I have an isopropyl on carbon 2. You go clockwise or counterclockwise. Most of you are going to go clockwise. So I'll put my isopropyl. And there you go. Now, there are 2 common names I asked you to learn. And here we have R in an aldehyde can be hydrogen, and we call that formaldehyde. Nobody ever calls that methanol. And I talked about the dangers of formaldehyde. Remember, if you know anybody who buys either new cabinets or anything, or furniture like for a baby's room, if it's not solid wood, you should have it tested for formaldehyde. Even though there are laws on the books to keep us protected, there are unscrupulous companies like Lumber Liquidators who imported stuff from China with high formaldehyde. When you have a ketone and our prime are both methyl, it's acetone. Nobody ever calls that 2-propanone. And on the test, if I asked you, which I did, one of these 2, draw the structure, I will never ask you what's the common name. Now, one of the most important things I would like you to know how to do is carbon double bond to oxygen is so important, even though it's not a functional group, it has its own name, and that's a carbonyl group. And you should know with both, excuse me, drawing and with words how to describe a carbonyl group. Carbonyl group, carbon double bond to oxygen, here's the general way. Now, how do you make a ketone or aldehyde? Well, I already went through this. Take a primary alcohol and oxidize it, you'll get an aldehyde. Take a secondary alcohol, oxidize it, you'll get a ketone. And next, we have a very special way of making it what's called an aromatic ketone, where one of the R groups in a ketone is a benzene ring. And these are used as things like sunscreen and for photochemistry as activators. And here, if I take benzene, this is an acid chloride, reacted with aluminum trichloride, I'll replace one of the hydrogens with the carbonyl with the R group from the acid chloride. That's called an acyl group. This is called acylation, Friedel-Crafts acylation. And what would be the two starting materials I would have to react to make that molecule you see on your screen? All right, I think everybody's done. Let's take a look at this. What's different? Ooh, carbonyl. Carbon's here, but a benzene ring, carbon's here. This is a ketone, but it's an aromatic ketone. And this is my R group. How do you make an aromatic ketone? React benzene. Don't forget to put the 3 bonds there in the circle, plus an acid chloride. And therefore, one of these question marks, doesn't matter which one you do, it's a benzene ring. What's my R group? G-butyl. And that's how you do it. Next, we started talking about reactions of aldehydes and ketones. And for most of these, both undergo the same way. So as you see on your screen, you have aldehyde or ketone. When R prime is hydrogen, it's an aldehyde. When R prime is carbons, it's a ketone. Reacted with an alcohol and acid, you get the hemiacetal. Now, this and the next 3 reactions, I will never put as a synthesis on the final exam, just like I wouldn't on an hourly exam. However, students have trouble with these. I would highly recommend you go back and do the practice problems for those type of reactions. Hint, I'd highly recommend you go back and do the practice problems for those reactions. And you take an aldehyde or ketone, one molecule of an alcohol, an acid, H plus is acid, you get a hemiacetal, hemiketal. Remember, keep your eye on the carbonyl carbon, carbon double bond to oxygen, because in ketones and aldehydes, that's always where the fun is. And you get this molecule. Now, if you use 2 molecules or moles of alcohol as catalyst with a ketone or aldehyde, you'll get the acetal or ketal, which, as you learned, was important in carbohydrate chemistry. And why don't you try this one? Boy, time flies when you're having fun with organic chemistry. Remember, you are having fun. If I say that enough times, you'll believe me. All right, I think everybody's done. Let's take a look at this. What's different? Ooh, carbonyl with hydrogen and carbons, aldehyde. Now, it could have been a ketone, but it's an aldehyde. Carbon-carbon hydroxyl group. Ooh, 2 of an alcohol. Acid catalyst. What happens? Keep your eye on the carbonyl carbon. What's attached to it, because you don't break carbon-carbon single bonds, is still attached to it. You open up the double bond to oxygen, make an alcohol, and this oxygen, oops, I'm thinking of the wrong one. You open it up to form this acetal or ketal. Our prime is hydrogen. Our double prime is methyl. R is ethyl. What's attached to carbonyl carbon is still attached to it. 2 oxygens, and each one has an ethyl group, and that's how you do it. Now, once you've made these, oh, by the way, a special case, when you take ethylene glycol, which is this, it has both alcohols in the same molecule, react with an aldehyde or ketone, you get the same thing. R is CH2, but there's a bond between those. And as I said for test 2, students a lot of times forget that bond, and I mark it wrong. Don't you forget. And that's a good way of putting on what's called a protecting group. Now, once you have the hemiacetal or ketal, add acid and water, and you'll get back the aldehyde or ketone you would have used to make that acetal or ketal, hemiacetal or hemiketal. And turns out the next reaction, you get the same products, you just don't balance it. If you have an acetal or ketal reacted with acid and water, you get back the aldehyde or ketone you would have used to make that, plus the alcohol, Now, for those who must, you can put 2 there. And I think I told you the story about these 2 twin sisters when I didn't balance things, got awful upset. I mean, really, they got bent out of shape. I tell them, hey, cool off, hang in, but and there you go. There's one for you to have fun with. Everybody see that okay? Okay. I just want to make sure that's an oxygen up there. And thank you for putting up with my awful handwriting at times. All right, everybody done? I think so. So let's get to work. What do we have that's, ooh, an oxygen there, an oxygen there, same carbon. On each oxygen, I have carbons. And over here, I have carbons to that carbon. So I have a hemiacetal or a acetal or a ketal. R prime in this case is this carbon, the other one is that part of the ring. They're connected together. Add acid and water. You get back the aldehyde or ketone you would have used to make that acetal ketal, plus the alcohol. For those of you who must, can I draw that any smaller? Now, this is R. The ring is R prime and R double prime. The carbon with the 2 oxygens will be double bond to carbonyl or oxygen, form of carbonyl. And the methyl group, you don't break carbon-carbon single bonds. And the alcohol is methanol. You don't have to put 2 there, but I guess those twins got me. All right. Oh no, our time's over. Time flies when you're having fun with Dr. White. Don't forget, study, use your tests as practice problems. I'll see you on Wednesday. Don't forget to hand the lab that's due Wednesday. And if you need any help, stop by my office hour. And now I get to say, gang gesund, be healthy. Bye.